Hey, yo, 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 yo. It's Mr. G, and we're going to talk more about some linear functions here in 3.2. So, first, what we're going to do is we're going to identify, evaluate, graph, and write linear equations as functions. Now, function notation is something we're going to talk about. It's a method for writing variables as a function of other variables. And then we also have linear functions, and linear functions are functions whose graph is a straight line. So for function notation, the variable of x is used to find the value of y. So what we do is we actually change these. I don't know why this is cutting off. I'm sorry. So y equals 2x plus 5. This is the equation of a line that we've learned in slope-intercept form. If I wanted to change this to function notation and write it as a linear function, I would just change the y to f of x equals 2x plus 5. These are actually the same thing, but we use the variable of x is used to find the value of y. So what I'm doing is this is the function where I can say this is the function of x. So whatever I plug in for x is what's going to determine the function of x. So this is read f of x. It's just a different way of writing these, and basically we're replacing the y with f of x. So what we're doing is the x is the element of the domain. Okay, so x is the element of the domain, and we plug that in to the function. And then here's the rule of the function. So this rule is 5x plus 1. Out comes whatever that function is of the input of the domain. So out comes the f of x, which we've also known as y. So it's just another way of writing the same thing. So this is just, here's my function, here's my rule, so I plug in my input, and out comes the output, and the output is just known as the function of that x. So how can we represent this in function notation? Instead of a y, it would just be f of x is equal to 5x plus 1. And that's it. So we're just replacing y with f of x. Now, we will sometimes have to write tables as, and we'll have to write a table in function notation. So the cost to make 4 bracelets here is shown in this table. So how can we determine the cost to make any number of bracelets? And I want to do this. We can determine this by writing the equation of this and write it as a function. So here I have my x, and then the bottom, instead of it being y, this is my f of x, because this is a function of the number of bracelets I make is going to determine the actual cost. So I have to write the equation of this. So there's 2 ways to look at it. If I look here, there's a pattern. It looks like it's going up by 15 each and every single time. So that's my slope, or my rate of change. It's changing by $15 each time. So if I continue that pattern going backwards to 0, that means at 0 bracelets, they spent $2. So that means the cost is probably $2 per, maybe they had to spend $2 on material at first, or there was an initial cost of $2 up front for something, and then they had to pay $15 more for each bracelet. So my rate of change is 15. And then my initial starting cost was $2 for whatever that starting cost was. That's one way I could have done this. Another way I could have done is I could have picked out 2 points, right? So I could have picked out the point 117, I could have picked out the point 232, and then I could have just written my equation from here. I like to just look at the pattern to figure out my rate of change as I'm going up 15 and up 1 each time. So my rate of change is just 15 over 1. That's my change in my y values. That's my change in my x values. So now I can use this to determine the cost to make any number of bracelets. If I want to know how much it costs to make 10 bracelets, I can do that. I can plug in 10, and then that's going to be 150 plus 2, which is 152. Now, the difference with function notation, though, is that when I plug in 10, really what I'm finding is well, what's the function of 10? So the function of 10 is, well, when x is 10, what's my final cost? So that's when I plug in 10 here to figure out how much it costs for 10 bracelets. And again, I just picked the number 10 out of nowhere. It's not that that wasn't part of this problem, but that's just for that any number of bracelets. So if I want to figure out a function of any number, if I want to figure out how much it costs to make 20 bracelets, I can plug in f of 20, because the function of 20 would be, well, whatever x is 20. So that would be 15 times 20 plus 2. And that would be 300 plus 2, so it'd be $302. Okay? So I want to skip ahead real quick to this problem right here. So that is more relating to this one as what is the value of f of -6 if f of x equals -8x minus 6. So here I have a linear function. I know it's linear because I have, this right side's in slope-intercept form. But it's asking me for f of -6. So it's just saying, what's the y value when x is -6? So the way I figure that out is I just plug in -6 for x. And then I just solve. -8 times -6 is positive 48 minus 6, which is 42. So f, the function of -6, is 42. And I'm done. I'm not going to write y equals because it wouldn't be necessarily in function notation. Okay? So I want to go back now. I'm sorry. So this one, I know this is hard to read. Okay? But what it started at was the initial temperature in Fahrenheit. The initial temperature in Fahrenheit was -3 degrees Fahrenheit. That's what that image is telling me. That when so Tamica records the outside temperature at 6 a.m. The temperature increases by 2 degrees Fahrenheit every hour for the next 6 hours. If the temperature continues to increase at the same rate, what will the temperature be at 2 p.m.? So this is the starting temperature when she recorded it at 6 a.m. It started at -3 degrees Fahrenheit. So here's what I want you guys to do. I want you guys to write the equation, or write the function, write the equation in function notation, and then let's see if you can do that on your own first, and then you can solve for what it would be at 2 p.m. So in function notation, I know if it's f of x equals. So we always start at, well, what's the rate of change? Well, the rate of change is 2 degrees every hour, so we're going to have x be the amount of hours. And then, but we always just got the y-intercept has always been, well, where did it start? Well, it started at -3 degrees. So I started at -3 degrees, but then I'm increasing, which is why this is positive, by 2 degrees every hour. So this is my equation. This is my function. Now, in order to figure out at 2 p.m., I don't just get to plug in 2 for x, because that's not what x represents. X represents the number of hours that has passed. Well, between 6 and 2 p.m., that's 8 hours. Because 6 to 12 would be 6 hours, and then another 2 would be 8. So I would actually figure out, well, what's f of 8 hours? After 8 hours, what's my temperature going to be? Well, that would be 16 minus 3, which is 13 degrees. So at 2 p.m., if it increased at this rate, it would be 13 degrees outside. Okay. Now we have a table that shows how many pizzas Antonio's Pizza Shop can make in an hour. Complete the table. Write the function to represent the number of pizzas Antonio's Pizza Shop can make in x hours using function notation. What is the reasonable domain and range for the number of pizzas Antonio can make? I want you guys to try to do this one on your own. So pause it, see how you do, and then unpause it and we'll see where we're at. Okay, so here's what I got. So if I notice they're increasing by 18 each time, so that means they're making about 18 pizzas an hour. Now here's where this one gets a little weird, is this is the rest of the table, but if they're making 18 pizzas an hour, why would they only make 13 pizzas in the first hour? Okay, so this is actually the equation, because if I continue that pattern, I'm going to be at -5 to start. Now, it doesn't make sense, is after 0 hours, they can't make negative pizzas. But what this means is that first hour, maybe it takes them a few minutes, maybe they lose that 20 minutes or so just in preparing and getting ready to start making the first pizzas. And then it starts to become 18 an hour, so that's how many less they can make in that first hour. So this would be the equation. But a reasonable domain would be, so the domain is between 1 and, would be anywhere between 1 and x would be in between 1. And technically, I would say 24 hours you can make an argument for. 24 hours because it's possible for a pizzeria to be open for 24 hours. Now, if you said maybe only 12 because most places are only open for 12 hours or so forth, that'd be fine. But really, you could technically be open for a 24-hour pizzeria. So the domain, reasonable domain would be any number between 1 and 24. Okay. And then for your range would then be, well, after 1 hour, they've made 13 pizzas. So then what I would do is for my reasonable range, I would plug in 1 for X to get 13. And then I would plug in 24 for X to figure out what's the maximum amount of pizzas that they can make if they follow the same pattern for 24 hours. So because it's not going to be all the numbers, it's going to be, well, okay, if they are open for 24 hours, then how many pizzas would they be able to make? So I would need to actually plug that in. Oops, I did this in the wrong order. I would need to do 18 times, 24 hours. And then minus that 5 for that initial first hour. So I need to figure out, well, what is 18 times 24? And I'm taking out my calculator real quick because I don't want to work it out. 18 times 24, that's 432. That's a lot of pizzas. Minus 5. So the reasonable range, if they were open for up to 24 hours, they can make up to 427 pizzas. So that would be my reasonable range. Okay. Finally, I think this is the last one. Oh, I got 2 more. Okay. This one, use the data in each table to write a linear function using function notation. Again, see how you do. Try this one on your own. Pause it, try it, go. Okay, here's all my work. So there's a few ways to do this, but I want to show you to find the slope. I just figured out my change in y over my change in x. Figured out what's happening. I basically subtracted here. I figured out my pattern was going up 0.8, and then I went up 1.2. And then the change in x's were up 4, up 6. These are really just points again. This is like the point -3, -0.6, and then this is like the 0.1, 0.2, right? And what I did is I just figured out, okay, well, I could have gotten, if I subtracted my x's, subtracted my y's, I would have gotten 0.8 over 4. And if I had used these 2 points, I would have gotten 1.2 over 6. No matter what, when I divide, I get 0.2. So there's my slope. Okay. So my slope it's increasing by 0.2. Now, I could have used that pattern to figure out what my y-intercept was, or I could have used point slope form right here. So I used point slope form, and I got my function notation of the y-intercept is just 0. So therefore, f of x is equal to 0.2 times x. So there's a few ways to do this one. I showed you the longer way, but that's how I found my slope. All right, and finally, if you're given a domain and you want to know the range. So if my domain, I know the only possible values for x are in between 0 and 50. Then that means what I need to do is I need to figure out, well, to figure out my range, I got to figure out what is f of 0. And then I got to figure out what is f of 50, because that means my range has to be when in between whatever these two values are. Because if I can use 0 for x, that's going to be the smallest value of this graph. So if I do 4 times 0 plus 5, well, that's just going to give me 5. So 5 is the minimum. If that's the minimum input, that means that's the minimum output. The maximum input of this function is 50. So therefore, I need to figure out, well, what's the maximum output of this function? And that'd be 200 plus 5. So that means if I can't go over 50 for my input, that means I can't go over 5 for the output. So then the actual range would be anywhere between 5 and 205, depending on what values I use. So there would be the range. Okay, now we're done. Go ahead and make sure you do your independent practice. And that's all I got for you guys. I hope this helped. Thanks for watching. Grudius out.